right, everybody. Ready for a deep dive into the fascinating world of desalination?
Absolutely.
You guys sent in some research on a new type of nanofiltration membrane, and it sounds seriously cool.
Yeah.
But before we get into the nitty-gritty of this new technology,
Sure.
let's take a step back and talk about why desalination is such a big deal in the first place.
Of course. Yeah. I mean, at its core, it's about addressing a fundamental human need.
Right.
Access to clean, fresh water.
Exactly.
And with growing populations, climate change putting a strain on our traditional freshwater sources, we really need to find new ways to secure this precious resource.
Absolutely.
Desalination offers a really promising solution.
It's like we're talking about tapping into the largest reservoir on Earth,
That's
right?
exactly.
The ocean.
Yeah, the ocean.
But I get the feeling that turning salt water into fresh water isn't exactly
Right.
a walk in the park.
Yeah,
Right?
it's definitely not easy. It's a complex process, and historically, it's been plagued by some real challenges. High energy consumption, environmental concerns,
Right.
and then, of course, the durability of the membranes themselves.
Yeah, it makes you appreciate all those times you just like turn on the tap and get clean water, right?
Absolutely, absolutely.
But speaking of challenges, this research you shared with us, published in the journal Desalination.
Interesting.
I mean, talk about a fitting title, right?
It's like it was meant to be.
Yeah. So what makes this research stand out from all the others?
Well, it all boils down to this material. It's called MXene.
MXene.
It's pronounced MXene.
MXene.
Yeah.
Okay, I've got to be honest, that sounds like something straight out of, like, a science fiction movie.
It does, doesn't it?
But I am here for it.
Okay.
Tell me more.
All right, so picture this. A material so thin it's practically two-dimensional,
Okay.
made up of these atom-thick sheets.
Wow.
That's MXene, a nanomaterial with some seriously impressive properties.
Okay, I'm trying to wrap my head around these, like, super thin layers.
Yeah.
We're talking about a huge amount of surface area.
Exactly.
Is that what makes it so suitable for desalination?
That massive surface area is key
Okay.
because it gives us more space to work with when we're trying to filter out those pesky salt ions.
Right.
But it's not just about the surface area.
Oh, there's more.
Oh, yeah. MXene is also what we call hydrophilic, meaning it's attracted to water molecules.
Interesting.
And get this, it's also electrically conductive.
Wow. It's like the total package.
It kind of is.
So how did the researchers actually use this MXene in a real desalination setup?
They incorporated it into a thin film nanocomposite membrane,
Okay.
or TFN for short.
TFN. Got it.
Now think of this TFN like a superfine sieve,
Okay.
but instead of just holes, it uses a combination of physical barriers and electrical charges to separate the salt from the water.
Clever. So we've got our high-tech sieve, and MXene is like the special ingredient,
Exactly.
the secret sauce.
And you know what they found?
What's that?
Adding this MXene to the TFN actually changes the membrane structure in a really fascinating way.
Really?
Yeah, they call it a crumpled surface.
A crumpled surface. What does that even...
Yeah, imagine you took a piece of paper and just kind of scrunched it up.
Oh, I see.
That's kind of what's happening at a microscopic level with this membrane.
So more wrinkles, more surface area, more places for that water to flow through.
Exactly. Right. That crumpled texture, along with MXene's natural, affinity for water,
Right.
it actually leads to significantly improved water flux.
So more fresh water, faster.
You got it. And it's not just, letting more water through.
Right.
It's also incredibly good at keeping the salt out.
Really?
Yeah, we're talking about significantly higher salt rejection rates.
Okay, now we're talking.
Right.
High water flux and high salt rejection. That sounds like a win-win to me.
It really does.
So did they actually, quantify how much better this new membrane performs?
They did, yeah. They tested it with a variety of different salts.
Right.
Sodium chloride, magnesium chloride, even some of the trickier ones.
Oh, wow.
Like sodium sulfate.
Making sure it can handle the real-world stuff.
Absolutely. Got to put it through the paces.
Yeah, for sure. So how did it do?
Well, across the board, the MXene-enhanced membrane it really outperformed the standard membranes.
Okay, give me some numbers. I love numbers.
All right. So for sodium chloride, for example, they saw water flux increases of up to 50%.
50%? That's huge.
In some cases, yeah. And even more impressively,
Yeah.
the salt rejection rate remained consistently above 99%.
99%. So for every, gallon of fresh water,
Yeah.
there's just, a drop of salt left behind.
Pretty much, yeah.
That's incredible.
That's pretty remarkable.
But there's got to be a trade-off somewhere, right?
Yeah.
What's the catch with this MXene membrane?
That's a great question, and it actually highlights another remarkable aspect of this whole thing. One of the biggest challenges with these desalination membranes is that they can be damaged by chlorine.
Ah, right, chlorine. Good for disinfection, but not so good for the membranes themselves.
Exactly. Over time, exposure to chlorine can degrade the membrane material.
Right.
And that leads to, reduced performance, shorter lifespan, ultimately means you have to replace them more often.
So how does this MXene membrane handle the chlorine?
That's where it gets really interesting.
Oh,
This MXene-enhanced membrane
yeah.
showed significantly improved chlorine resistance.
Oh, wow. So not only is it more efficient, but it's also tougher.
You got it.
This MXene is starting to sound like a game changer for desalination.
Yeah, I'd have to agree with you there.
I mean, this could have huge implications, right?
Absolutely. And it's not just about improved performance and durability.
What else?
This technology could also lead to some real economic and environmental benefits as well.
Okay, now you've got my attention. Tell me more about these potential benefits.
Well, for one, if these MXene membranes last longer, you need to replace them less often, right?
All right.
That means lower costs for desalination plants.
Makes sense.
And if they can operate more efficiently, use less energy to produce the same amount of clean water.
Right.
Well, that's good for the environment, and it's good for the bottom line.
It's like a ripple effect of positive impacts.
Exactly. Exactly.
This is why I love, digging into this kind of cutting-edge materials science.
Yeah.
It's not just about the material itself. It's about how that material can be used to solve real-world problems.
Absolutely. And this research is a perfect example of that.
Yeah.
But, what I find really fascinating is that this might just be the tip of the iceberg when it comes to MXene.
Wait, really? There's even more to this wonder material.
Oh, yeah. Researchers are already looking into how we can use MXene for all sorts of things, like energy storage,
Wow.
sensors, even biomedical devices.
It's like Swiss Army knife of materials.
It kind of is.
I love it.
Yeah.
So we started with desalination, and now I feel like we're uncovering this whole universe
Yeah.
of MXene-powered innovations. What was the most surprising thing you learned from this research?
Honestly, beyond the performance numbers, which are really impressive,
Yeah.
it was how elegant their approach was.
What do you mean?
They didn't try to reinvent the wheel, They
Yeah.
took existing membrane technology and just made it better.
I think
Just by incorporating this, remarkable nanomaterial.
so smart. It's like they found this perfect ingredient to add to the recipe.
Exactly. It speaks to the power of smart material design,
Yeah.
and how nanotechnology can help us tackle these really big global challenges.
Absolutely. Working smarter, not harder.
Exactly. That's the key.
This has been amazing, but you know me, I always have more questions.
Of course.
Like, how do we actually scale up production of these MXene membranes?
Right.
Can we make enough to meet the needs of these large-scale desalination plants?
Yeah.
Yeah, what are the roadblocks we still need to figure out?
Well, you've hit on a really important point. Yeah.
It's one thing to demonstrate something like this in a lab,
Right.
right? Controlled environment, small scale,
Right.
but scaling it up,
Right.
that's a whole other challenge.
Totally, totally. So what are the biggest hurdles?
Well, we've got to think about the production of MXene itself.
Okay.
Can we actually make enough of this stuff?
Right.
And can we make it affordably?
Right. Got to be cost effective.
Exactly. And then there's the manufacturing process itself.
Yeah.
We need to make sure we can produce these membranes consistently
Right.
on a large scale and make sure the quality is top-notch every single time.
It's like you can have the best recipe in the world, but if you can't replicate it,
Exactly.
it's not going to work.
It's not going to fly.
And then, of course, we have to think about how these MXene membranes will actually perform in a real-world desalination plant, right?
Absolutely. Yeah, lab tests are great.
Yeah.
But those plants are tough environments.
Right.
All sorts of different water chemistries.
Right. Potential for fouling. We got to make sure these membranes can go the distance.
So it sounds like there's still a lot of work to be done
There is.
before we see MXene membranes everywhere.
Yeah.
But even so, I'm really optimistic.
Yeah.
I feel like we're on the verge of something big.
I think so, too.
It's like a new era for desalination,
It really is.
powered by these incredible tiny materials.
It's amazing what we can do at the nanoscale, right?
It really is. It makes you think, what other breakthroughs are out there? What other problems can we solve with material science?
Exactly. The possibilities are really endless.
Well, that's a perfect note to end on, don't you think?
I think so.
A huge thank you to our expert for joining us
The pleasure was all mine.
and for taking us on this incredible deep dive.
Anytime.
And to our listeners, thank you for joining us. Keep those curious minds engaged, and we'll see you next time for another deep dive.
See ya then.
Bye, everyone.